Mass, weight, and normal force. Mass is the measure of the inertia of an object, the resistance of an object to accelerate. In the SI system, mass is measured in kilograms. Mass is not weight. It is a property of an object. Mass is how much stuff is in something. It doesn't depend on where the object is located. Weight is the force exerted on that object by gravity. If you go to the moon, whose gravitational acceleration is about 1/6 of g, you will weigh 1/6 as much as you weigh on Earth. Your mass, however, will be the same. And click on this link to see a Veritasium video about mass and weight. Weight is the force exerted on an object by gravity. Close to the surface of the Earth, where the gravitational force is nearly constant, the weight of an object of mass m is calculated as, we have Newton's second law right here, F sum of the force is ma, the force of gravity is mg, and it's always pointed down. Weight is shown as either w or F sub g or mg. The acceleration of any object in free fall is g. Near the surface of the Earth, g is 9.8 meters per second squared in the downward direction. The Earth attracts all objects. Earlier in this unit, inertial mass and gravitational mass were defined. Another way to look at these two definitions is that the mass on the left side of the equation, over here, force of gravity, mg, is the gravitational mass, and the right side is the inertial mass. Since they are both numerically the same, the equation reduces to g equals a. So the acceleration of a mass in a gravitational field is equal to g. An object at rest must have no net force acting on it. So if it is sitting on a table, right over here, the force of gravity is still there. But additionally, what other force is there? The force exerted perpendicular to a surface is called the normal force, F sub n. It is a pushing force and is always perpendicular to the surface. That is key, perpendicular to the surface that is pushing on the object. The table is pushing on the vase, exerting a normal force. And that vector is right over here. The normal force is exactly as large as needed to balance the force from the object. If the required force gets too big, the table would break. The words normal and perpendicular are synonyms. So here's our normal force up, gravitational force down. If neither the table or the vase is moving, then the sum of the forces acting on it are zero. So normal force minus mg is equal to ma, Newton's second law. Normal minus mg equals 0. So the normal force equals the weight of the object, mg. Example 1. Find the weight of a 2,000 kilogram elephant. We have our givens. The mass is 2,000 kilograms, and they didn't give us acceleration, but g is 9.8 meters per second squared. Use the weight equation, where weight is F sub g is mg, here's the mass, here's g, and the force of gravity is 19,600 newtons. A car weighs 14,500 newtons. What is its mass? This is example 2 for mass and weight. The givens are the weight, which is the force of gravity on the object, 14,500 newtons. Here's g again, gravitational acceleration. Use the weight equation, W equals F sub g. So here's F sub g is mg. Isolate mass by dividing both sides by g. Substitute in our numbers, and we get a mass of 1,480 kilograms. Example 3. A book of mass 0.85 kilograms sits on a bookshelf. What is the magnitude and direction of the normal force that acts on the book? The givens are the mass, and of course the value of g. The normal force is in the opposite direction and is equal to the magnitude of the force that the book exerts on the shelf. The force that the book exerts on the shelf is equal to its weight. W, weight, equals F sub g. So the normal force is equal to F sub g. We substitute in mg for the force of gravity, substitute in our numbers next, and we get the normal force is 8.3 newtons in the upward direction. Finding g graphically. The value of g can be determined by using a spring scale and a box of objects that have their mass printed on them. Weigh each object with the spring scale and create a table with the weight, F sub g equals mg, and the mass that is printed on the object. Rearrange F sub g equals mg to be F sub g equals gm. Now why are we doing that? The equation is now in the y equals mx plus b format, where b is 0. Okay, there's no intercept there. Plot F sub g on the y-axis and mass on the x-axis, and the slope of the line will be g. Right, because here's our g, and that's going to be this term right here. Plot the points from the table. The table here, this is the data that we're taking, and draw a best fit line. The slope of the line is the value of g. So our y-axis is F sub g in newtons, and then we have mass in kilograms. We have our data points, see there, here's another one. The best fit line comes up with a slope of 9.8, which is the value of g.